Our next speaker is Steve Gorelick. Steve is a hydrogeologist and hydrologist whose research involves the study of water resources and water security with an emphasis on freshwater. Using lab and field data, his research group aims to develop an understanding of fundamental aspects of the transport of water and contaminants and to investigate regional water resources system. Steve received his bachelor's from New College and a master's and a PhD in hydrology from Stanford. He is currently a professor in Earth System Science and a senior fellow in the Woods Institute. Steve also directs the Global Freshwater Initiative with past and active projects in India, Mexico, Vietnam, and Jordan.
All right, well, I didn't get the TED part of the TED Talks. It's just a talk. So, I'm going to talk about challenges that we're looking at in freshwater vulnerability in a coupled human-natural system. We worked in Jordan, and that work is done pretty much, but I'm going to talk about ongoing work we're doing in India. And this is part of what is called the FUSE project, and it's Food, Water, Energy for Urban Sustainable Environments. And the goal is to provide a window into the future to see which sustainability interventions and policies might work and which ones wouldn't or have no chance of working. And so this group of about 30 people in 4 different countries have expertise in water resources, hydrology, food security, agriculture, energy, climate change. We have a big economics group, a good group in urban sociology. We have professional facilitators and stakeholder engagers, and then we have integrators of our models. Here on campus, I have a postdoc visiting from Germany, from the Helmholtz Institute, Christian, and then a doctoral student, Kuhn, who's from Stanford, and the other 2 groups are Yasa and Ofsi in Austria. So the study area is a place called Pune. I suspect that most of you have never heard of Pune, but it's becoming a mega city. It's about 91 kilometers from Mumbai, or miles from Mumbai, and it's inland. Mumbai is on the Arabian Sea, as you can see on this picture on the left, and then Pune is inland, and the flow of water, which is pertinent here, is shown in this Bhima Basin. Bhima Basin's about 1/10 the size of California. If you don't like that, 2 times the size of Massachusetts, or about the size of the Netherlands. So that's the scale of this. And so Pune is this red blob there in the middle, and it's fed by the Mula and Mutha rivers, and I'll show you more about this in just a second. I want to make an important point. There's no major city in India that has a pipe water supply, 24/7 pipe water supply. They have a pipe water supply, but not 24/7. And they face a lot of different challenges. We talk a lot about climate change, but what you'll see here is that it's more than climate change. It's climate change, there's population growth, there's uncertainty in economic development. We don't know the trajectory of these places. And reservoirs are managed for droughts, but what I want to show you here is something I swiped off of the internet on a news station. This is 20 seconds, 10 days ago in Pune. The monsoon is presumably done. As I said, most of you probably haven't heard of Pune, and I doubt that anybody's seen this in the news. So, if you look at the country as a whole, and you look at this data that were from April to 20th to March of 2020 to 2021, you'll see that there's, in Maharashtra, which is one of the 28 states in India in which we're working, the state in which we were working, and in which Pune resides, there were 215 deaths in this period. And if you look at the rest of the country, I've highlighted these in these arrows, 1,984 souls are reported dead, and not everybody's even reporting. And if you look back at the data, there's 1,500 flood deaths per year since 2010. So flooding is a huge problem. And the destruction is unbelievable. This is in 2019. Have you ever even heard of this? I mean, this is in Pune. Look at the catastrophe here. I mean, it's totally flooded. And this is happening every few years in a place that's just in dire need of help and floods. So, Irene here is a postdoc in the group, and she's working on really simple methods to try to understand flooding and to get flood models. Now, there are sophisticated models, but they just aren't pervasive throughout India, and there's reasons why they just don't do it politically. because there's land involved and there's interests that don't want to hear that they're going to get flooded. So she's developed a very simple model to show the flooding, and you can see the heights of water. And there's also other data we can superimpose upon this to show that there's 17% of this area is slum areas. If you look at take the population of the United States, cut that in half to about 170 million people, that's how many people live in slums in cities in India. Half the population of the United States, huge number. So that's one part of what we're working on now, is to try to develop these flood models in a way that we can pump out and use in other places besides what's going on the Mutha River going through Pune. Climate change. We're going to compare the last 30 years to the next 30 years in climate change, and the models are all over the place. And it suggests that it's going to be, on average, about 2 degrees hotter, but there'll be way more hotter days than there were before, 41 versus 24 of above 104 degrees. Rainfall, it looks like it'll actually increase when you average it, about 7% increase between now and mid-century, and greater climate extremes with succession of floods and droughts. They manage their system for droughts, not floods, by and large. We have a group developing projections of what the population looks like going from 2015 to 2050, and it's a projection of population and how population will grow demographically using a pretty fancy model, but it shows this agglomeration between Pune and the gold area on the left up here, and there's an area called Pimpri-Chinchwad, growing together to be this megalopolis. And in this entire area, this area that's shown on the screen is not the area of the Bhima Basin, it's just the area that will perhaps eventually be considered an urban area. So big population growth. So in 2019, we had stakeholder workshops, and those were incredibly moving and important in this project. They involved people in government, ex-people in government, people from NGOs, consultants, academia, and they were carefully selected based on a stakeholder engagement, a stakeholder analysis project. One person in the project lived in India for 2 months to pick out who should come and who should not come. And what they gave us was their challenges, what we saw as their future challenges, and their ideas for solutions. So among the things I'll just point out, and there's way more than this, and we've written on this, that there is non-revenue water that's stolen or missing. There's intermittent water supply. There's no regulation on groundwater abstraction. There's sugarcane dominance, and that's the major water user. It's also the major moneymaker agriculturally. And then they have droughts and floods and such. So we got those challenges, and then we worked on this, and I'll show you what we've done. But we worked, and we come back to say, okay, we're going to show you some results, and I'll just show you one result because I don't have time to do anything else, and get your take on this and give us more ideas about what we need to do next. So we had about 80 stakeholders to start with in 3 different workshops in both times, and about half of those people came after COVID, and the same people, and others were surrogates in the same fields or in the same offices. So we have these different potential solutions to try to overcome droughts. We have this food, water, energy triangle with urbanization in the middle. And what we're going to focus on and what we showed them are a tanker water market, which I'll describe, demand management in which you can have caps on pumping, for example. You can have water coming from reservoirs to overcome a drought that are water's going to Mumbai, and it goes to Pune instead and sacrifices the hydropower. And then the one I'm going to show you is ag to urban, where agricultural water, we have a water market in which we buy the agricultural water and give it to the city. But there's other ones, solar farming and subsidies for sugarcane and such, that are in question. So you've seen some things about scenarios. Okay, those are the climate and population change. And then you have interventions. And then we end up wanting to get these metrics, and these are metrics of well-being. And those metrics involve vulnerability. And for the vulnerability metric I'll show you, it's what % of the population gets less than 40 liters per capita per day. That's 10.5 gallons per person, a really minuscule amount of water. How long could that last? what's the social inequity and what's the economic well-being. I'm just going to show you the first one. So what's this model? This is going to be laughable at the end, but I want to show you what it is to start with. It's a very complex, very believable, very credible model for the people that we engage with. And there's human modules. So there's farmers, there's people who live in cities, in the slums. We have surveys of 1,900 households for the entire city, including slum and more information on the slums. And then we have industries. Then we have the institutions which determine how much water is gotten and how much water can be given to these different places. And so there's decisions being made for demands for water and then provision of water. And then we have biophysical modules. So we have crop yield, we have a surface water module, which is a very detailed model of the hydraulics and rainfall runoff for the system. We have a full complex groundwater model for the system, and then we have energy for water. And so you have, again, these decisions being made on withdrawals and abstractions and choices of crops. Okay, so we start with, then we go to scenarios. There's climate forcings, there's economic development, there's population change, the things that I've mentioned so far. And then superimpose on that, when we're all done, this is the laughable part, we've gotten this complex. If I showed this at the beginning, you wouldn't even paid any attention, right? So we have crop policies, we have subsidies and quotas on these various things. You can have reallocation, you can have regulations. So that's the kind of things that we're playing with in the model. Now, one thing you see in one of the climate models is that there's a drought that shows up, and in one of the climate projections that shows a 3-year drought. And we're saying, well, could they survive a 3-year drought? And this drought could be at any time. It doesn't have to be in 2050. We're not projecting that. We're just saying, okay, what if it was there? And we do see it in the climate model projections. And so we're just going to call those years 1, 2, and 3, so there's no mistake that we're saying that this is a projection. And so we have a business as usual case, and we'll start out with what they do if they don't do any drought mitigation. And what you see in these countries when there's a drought is there's a tanker truck line that's going to be as far as you can see of people bringing in water into the city to provide water. And this is happening all over the world. Okay, so what do you see in the business as usual case? You see, this is liter per person per day, okay, under the normal climate, and then you see those 3 years. And what you see immediately is that the low-income people, this is in liters per capita, so the 74 there is about, what is that, 20 gallons, and then this is 182 is 48 gallons. So the high-income people get 48 gallons, and then the low-income people get much less. And that declines over the times when of the sequential droughts to where you're getting, 3 gallons and 6 gallons for the poor. So this is untenable, right? This is a disaster waiting to happen. So then we say, okay, what's the best possible solution? Is that of all the things we came up with is to have a water rental market where the farmers farm, we pay for their profits, and you say, okay, you don't use your water, you let the tanker trucks take that water into town, you have a much bigger tanker market because there's no other good way to get that water distributed, and you go explore outside the city. And what you see is our metric is what percent of the population is receiving less than 40 liters per capita per day. And this is under the business of usual case. And again, you see the poor people, the blue lines, and those are exceeding 50%, up to 70, 80%. And the middle class and the richer people do poorly when you get to the 3rd year of the drought. Okay, so now what happens when you introduce the tanker market? I'm just going to show you the last 2 years of the drought. And you see, okay, there is some help for the middle class and the rich people going from this metric, from the business as usual over to the time in which you have the tanker market, the agricultural buy-in, and then the 3rd year it doesn't work anymore. They're just out of water. Okay, the reservoirs dry up. There's not a lot they can do, and they have quite a bit of storage there. So that's a problem. Now, the other thing that happens when you have this kind of tanker market is we have a very comprehensive groundwater model, and what the picture on the top left is what happens when there's no drought. Okay, the blue is the aquifer's full, okay, and as you get towards the red on these pictures is when the aquifer is dry, and we mean dry. And so what you see is around the city, if you look at year 3, this is a blow up of it on the left. is that's when you have basically the aquifers dry in the vicinity of 20 kilometers on either side of the city. Okay? So not only is the surface water system not adequate, but the groundwater system is also a problem. So obviously you're going to have to do more than just this. Okay, so that's where we are. We have this group of very engaged people. It's amazing to me when I talk to the folks in India at these stakeholder meetings that they are so grateful because they realize they have, they're dealing with day-to-day, week-to-week, month-to-month kinds of things. They're thinking long-term, but not enough. And they know they don't have the capacity to do with this, and they're embracing it. And the NGOs are actually talking to each other about, let's do something. Let's get together and make noises, because it's a very bottom-up society. So we're working with the NGOs and the government agencies to identify a path to sustainability. And, you know, through some magic where we combine different interventions, we try to help them with their water scarcity situation. So that's the last slide, but I want to show you one other thing as an advertisement. We do have an upcoming special event on frontiers and coupled human-natural systems that will be head by the business school on December 2nd and 3rd, and you have to register if you want to come, and it's going to be great, and we have a lot of really terrific speakers. Thank you.